one thing that I noticed when I was looking quickly through the questions that people had about the topic so far, and also something that I noticed when people were coming up to me after class and in office hours, is that a lot of folks really have no idea what the significance of root mean square speed is. And so I want to try to make that clearer for y'all right now. It is a little bit difficult because describing the motions of these gases, a lot of times you need some pretty high-level math to do that. And we're sort of working with kind of basic algebra. So if you go on to physical chemistry, a lot of this is going to become clearer. You're going to get into this in a lot more detail. But I think that we can explain it pretty well using the tools that we have. So if you'll remember that chart that was looking at different molecular speeds, like the distribution of molecular speeds in a sample of gas, there were 3 speeds that were highlighted. The first one was the speed that was right at the top of that curve. You remember what that speed was called? The most probable speed, right? That's UMP, our most probable speed that a molecule would have. We also have the average speed, just the average speed of all molecules, and we have our friend root mean square speed. All right, now I'm going to write out this definition. I said it in class. I think I wrote it out in class, but we're going to write it out again. The root mean square speed is the speed of a molecule, a gas molecule, or an atom if it happens to be like a noble gas molecule possessing kinetic energy identical to the average kinetic energy of the sample. All right. So it's how fast a molecule has to be going to have a kinetic energy identical to the average energy of the sample. All right, so it's slightly different than the average. The reason why it's important is because the kinetic energy is related to 1/2 mass times root mean square speed squared. All right, that's one reason why it's so critical. Now I want to explain a little bit using some pretty basic math about why you get different values for average and for root mean square. Because I think that's something that a lot of people are getting really confused about. All right, so I'm going to give you an example of how you calculate an average. I know everybody knows how to do this. But let's imagine that we have 4 objects, and one's moving at 4 meters per second, one at 6 meters per second, one at 10.0 meters per second, and one at 12 meters per second. All right, now I want to find the average of all those speeds. So what do I need to do? Add them and then what? Divide by 4. Good. All right, so let's do that. For the average speed, I'm going to have 4 plus 6 plus 10.0. I really should have my units. Divided by 4. And I should get that my average speed is 8 meters per second. Okay, great. All right. Now let's calculate the root mean square speed for these 4 objects. And you'll see we're going to do it a little bit differently. To calculate the root mean square speed, you're going to take the square root of the average squared speeds. So a little different procedure here. So we're taking the square root of the average squared speeds. That means that each of these speeds is going to be squared. Okay, each of those is squared. All right. So we're taking the average of those squared speeds, and then we're taking the square root of the whole thing. When we do that, we get, for the root mean square speed, 8.6 meters per second. Do you need to know how to do this? No. But I just wanted to show you guys that so that way you knew that there is a mathematical reason why there's a difference between average and root mean square. Again, this is not going to be tested, but just know that the fact that there's a difference doesn't have anything super profound. It's just a different way of calculating things. It's thrown off because we're taking the square root of squares.